available. If someone was absent or behind on assignments or something, I can listen to those. All right, first of all, go to section, 9.5, and I don't know that this follows exactly. You might just go to the back side and do the calculating things, and then fill in the note side when we're ready. I want you to find the perimeter and the area of this rectangle. So draw yourself the rectangle so you know what the measurements are. We won't use the whole paper yet. Find the perimeter, find the area. Lucas, what's the perimeter? 22, and what's the area? 28. And label the units. Perimeter is feet, area is square feet. Okay, now that was not a difficult task. What we're going to do now is change that rectangle. Let's make it 3 times as tall. So yeah, I'm going to go back to this so that you don't have to do it the way I did. But now draw a rectangle beside that is 3 times taller, but still the same width that we started with. Figure the perimeter, figure the area. First, you probably have to figure out how tall is it. 3 times taller.
Go for it.
So 4 times 3, now the height is 12. Figure the area, figure the perimeter. What's the perimeter? 30 feet? Okay. 38, okay. And what's the area, Kieran? 84 for the area. And looks like I did not redo, okay, I didn't redo the perimeter, I guess. Okay, 38 was the perimeter. Okay, what I want to do is kind of compare. The original figure had 22 for a perimeter. When you made it 3 times taller, it was 38. Okay. Any relationship between 22 and 38? Like, did it get 3 times bigger? Perimeter. No. Why did it not get 3 times bigger? No, we went 3 times taller, but we didn't make it 3 times wider. So we didn't take every side times 3, so the total perimeter is not going to be times 3. Okay? What happened to the area? What was the new area? 84. So is there a relationship between the 28 we started with and 84? Did the area get 3 times bigger? Yes? Okay. Now you can visualize that by what I did. I divided it into 3 actual rectangles. So if you knew the area of one of them, then taking it times 3 gave you the area of the taller rectangle that you created. Now a question that would be on the assignment would be, triple the height of the rectangle, describe the effect on the area. So what you would do is do your figuring, and to answer the problem, you're going to say the area is 3 times as much. If you want to use the word tripled, you can. That's what that means. I won't ask you, or the book won't ask you about the perimeter, because the perimeter is not predictable what's going to happen to it if you only multiply the height by 3. You have to really do both of them. So let's try both. If we triple the base and the height, so we're making it 3 times taller and 3 times wider. What's the new perimeter? Now the height is 12, and the width is 21. New perimeter is 66. What was it to start with? 22. So now that we tripled both the height and the width, the perimeter did get 3 times as much. Original area was 28. What's this bigger one's area? What's 12 times 21? 252. Did that get 3 times as big? Didn't get 3 times as big. How many times bigger did it get? 9 times bigger? Now why did it get 9 times bigger? Right, it's area takes in 2 dimensions. That's why we have the units of like square feet. So if you are multiplying by 3 in one direction and you're multiplying by 3 in the other direction, area uses both of those, and we're multiplying by 3 times 3, 9. It's 9 times as big if you do change both dimensions. All right, so we would answer perimeter tripled and the area was multiplied by 9. Okay, let's start with a triangle now. Then we'll need the starting perimeter and area. Find the missing side, don't you, for the perimeter? Pythagorean theorem, or you know that triple by now? 3, 4, 5 makes a right triangle. So the perimeter was 5 plus 3 plus 4. That's the perimeter. 12? What's the area? 6. 6 square feet and 12 feet. Okay, got those written by that shape? Okay, let's do a change to that triangle. Now remember, if we change it one way, it only changes the area by whatever we do. But if we change it both ways, it's going to affect it twice for the area anyway. Okay, double the base of the triangle. Don't make it any taller, but double the base. Now before you calculate, if you can think what we did on the last one, if we change just the base and double it, what's going to happen to the area? You think it might be twice as big? Or 4 times as big? Twice as big? Okay, let's calculate and see. What's the new base? 8. 8 times 4, or 8 times 3 is 4, and half of that because it's a triangle, 12. So how does that new area compare to the area we started with? Did it get twice as big? Did it double? Yes, it did. So doubling the base determine the effect on the area. So the answer we're looking for is the area is doubled, or the area is multiplied by 2. I'm not going to ask you about the perimeter because if you only stretch it one way, the perimeter is not predictable what it's going to end up in. Now let's double both the base and the height. So we're making it 2 times wider and 2 times taller. I help you draw your new triangle, 2 times wider, 2 times taller. Get the right measurements on there. 2 times wider and 2 times taller. What's that going to do to the hypotenuse?
Maybe 2 times.
Yeah, it'll get 2 times longer also. What do you think's gonna happen to the perimeter? You double
Double,
every side.
double.
You double the perimeter because you double every side. What's gonna happen to that area? Remember, area considers two dimensions. So if we double it one way and we double it another way,
So 400 again.
so we're taking the area, not 8 times as much, it shouldn't be.
24.
What's the new area?
24.
24, and it was 6 to start with? So what happened to the area? 4 times, quadrupled, yeah. 2 times one way and 2 times another way makes it 4 times as big. So we would say the perimeter did double and the area was multiplied by 4, or you could use the word quadruple. Now if you get to the point that you understand what's going on, you don't have to calculate all the time. I want you to get to the point that you understand that if we double both dimensions, the perimeter is going to do the same thing and the area is going to do that twice. Double it one way and double it another, which means multiplying by 2 and 2, which is 4. All right, let's have you write this down in your notes. I don't know if I put part of it to start with or not. Is that kind of in the middle there? I don't know if I put these words or not. If not, write down my sentences here. If you change only one dimension, I tried to put that in red, but it didn't show up. If you change only one dimension of a figure, the area changes in the same way. So if you are making a figure twice as tall, the area is going to be twice as much. If you are making the figure 5 times as wide, the area will be 5 times as much as it was. So when I say changing it only in one dimension, you're only changing the height or only changing the width of it. Second sentence, if you change both dimensions of a figure, change its height and its width, the perimeter changes in the same way. If you're making it 3 times as wide and 3 times as tall, the perimeter will be 3 times as much. You're taking every measurement times 3. When you add it up, it'll still be 3 times as big. And the area changes by whatever the change is squared, because you're doing it 2 dimensions. The key to this section is paying attention, am I changing one dimension or 2? Now there are some shapes that if you change one, it's automatically going to change the other one. For instance, a circle. If you change the radius of the circle, doesn't that change both the height of the circle and the width of the circle at the same time? What else would that happen on? A square. If you have a square and you want to keep a square, if you make the bottom side wider, it's going to make that square taller at the same time. Otherwise, it's going to turn into a rectangle. So there are some shapes that if you change one dimension, it's going to change both at the same time. Okay, so let's practice here a little bit. Okay, if I am making a shape 1/3 as tall, what's going to happen to the perimeter, or the area of it?
1/3.
It'll be 1/3 as much as it was. If I am making a figure 1/3 as tall and 1/3 as wide, what's going to happen to the perimeter? It'll be 1/3 as much. What's going to happen to the area? 1/3 times 1/3 is 1, 3 times 3, 9. 1/9 as much. Does that make any sense? Let's see if it really is. Describe the effect of the change on the perimeter and the area of the rectangles. We're not going to try and draw it and recalculate unless you really have to. Let's see if you can figure out based on those 2 sentences. Okay, so the change on the perimeter and the area. Okay, the base and height of a rectangle, I'm even going to skip over the measurements, are both doubled. The base and height are both doubled. So are we changing one dimension or 2? 2. So look at your notes there. What did you write down? What happens to the perimeter? perimeter, what happens to the area?
Big.
The perimeter is going to double, multiply by 2. The area is going to
Change squared to 4.
multiply by 4. 2 squared,
Yeah.
4 times as much. We don't really have to recalculate. Okay. How about we've got a regular hexagon. The base and height of the regular hexagon are both multiplied by 1/3. So everything's going to be 1/3 as big. What's going to happen to the perimeter total? Changing both dimensions, same thing that we did on the last screen. So the perimeter is going to do the same thing that I'm doing here. Perimeter is going to get multiplied by 1/3. Area, if we're changing both dimensions, is going to square whatever we do. So multiplied by 1/9 as much. Okay, this is about the circle. I mentioned that just a little bit ago. If you change the radius of a circle, it changes both dimensions. So what's going to happen to this circle? The radius of the circle is multiplied by 1/5. Is that going to make it bigger or smaller, by the way?
Smaller.
Smaller, 1/5 as much. Describe the effect of the change on the, I'm using the word circumference instead of perimeter, but it's a circle. What's going to happen to the circumference? Is this changing 1 dimension or 2 dimensions? When we change the radius of the circle? Both. So what's your note say? If you change both dimensions, the perimeter changes in the same way. So the perimeter is going to be 1/5 as much. Okay, I did some calculating, I'm going to skip that. Just the circumference is going to be 1/5 as much. What's going to happen to the area? What's 1/5 squared? 1/25. So the area is going to be 1/25. Now, did that work out with my calculations? Did the circumference get 1/5 as much? Did the area get 1/25 as much? So I did the calculations to verify what happened there. Square, we're going to multiply the sides by 8. It's going to get a lot bigger. Write down on the marker board so I can tell who's with me. Marker board. What's happening to the perimeter? What's going to happen to the area? You don't have to recalculate unless you need to. Decide if it's changing 1 dimension or 2, changing the size of the square, multiplying them each by 8. What's going to happen to the perimeter and the area? And if you just want to put like P times something or P divided by something. I don't need to know the new perimeter or area, just tell me what's going to happen. Is it going to be multiplied by 8 or by 16 or 64 or what's it going to get multiplied by? What is the effect of the change on the perimeter? What's the effect of the change on the area? Read your notes. What happens in both dimensions? Both dimensions, perimeter changes in the same way. So if I am multiplying the sides by 8, so it's going to divide the area, no, that's not what happens to it. Okay, what should be happening is the perimeter gets multiplied by 8. And I'm not asking you what is the perimeter, just what's gonna happen to it. The perimeter is going to get multiplied by 8, and the area is gonna get multiplied by 64. Not what is the perimeter, but what's gonna happen to the perimeter. Okay, let's try and, I think I need to have you do another one. Let's say, let me see if I had another one after. This is the way the theorem says it. I don't like the way the theorem says it. Okay, if the diameter of a circle is multiplied by 4, diameter of a circle is going to get multiplied by 4. What happens to the area? Look at your notes there. Was changing the diameter of the circle, changing it in 1 dimension or 2 dimensions? Be both. So if you're changing both, your notes should say the area is affected by whatever the change is squared.
So this,
Yes. Yes. Tell me what's going to happen to the area. I don't care what it is. What's going to happen to it? Says the area is going to be changed by whatever changes squared. Yes, exactly. Yes. The change squared. We multiply by 4, but we square it. What's 4 squared? 16. So you should say the area is going to get 16 times bigger. I'm not saying what it is, just it's going to get 16 times bigger. If the radius of the circle is multiplied by 9, what happens to the circumference? That's my perimeter. On a circle, changing the radius changes both dimensions.
that's not 8. Oh, it is?
Same way. So the circumference is going to get multiplied by 9. Equilateral triangle. If the side is multiplied by 10, on an equilateral triangle, if you change one side, is it going to change all sides? Yeah, so we're changing both dimensions. What happens to the perimeter? What happens to the area? Not sure? Did you notes written down? Remember changing the same way. You didn't get the rest of the sentence though. You got the rest of the sentence. Same way, and the area changes and the change squared. To do that last part there. Okay. So we're changing both dimensions here. Changing both dimensions. So the perimeter is going to change in the same way. At the bottom, the area is going to be multiplied by that squared. Okay, so the perimeter is going to get multiplied by 10. The area is going to get multiplied by 100. Where did I get 100? 10 squared. All right, let me click to something else here quick. The section that we're going to do back, do you remember this theorem back in section 7.5? And I know I need to hustle here. We're going to use this to find a missing perimeter. Okay, let's do this one. Okay, write this one down, and we'll see if that will, let's give you a lead in to do this section. Then we gotta get to your quiz. Okay, we have two triangles here. They are similar. So there's a larger version, a smaller version. We're gonna try and actually find the missing perimeter and the missing area. So it's using what you were just thinking about, and I'm gonna show you how you can use the proportions we did last chapter to find the area. Okay, perimeter of the first one we do know, 36 centimeters. Perimeter of the second one I don't know. I'm gonna put a P. What ratio should those perimeters be in? Perimeters change in the same way that the sides do. The ratio of perimeters and the ratio of sides are always the same. So the sides would be in the ratio 13 to 9.1. Where did I get that? I just took the matching side measurements and made a ratio out of it. These are the sides compared. This is the perimeters compared. They are equal in ratios for the effect of what's going on. So you can cross multiply and find the perimeter of that second figure. 25.2. The perimeter here is 25.2. Makes sense, it's smaller. Now if we're doing the area, the first one is 60 square centimeters. Area of the second one, I don't know. Now, does the area change in the same way that the sides do? These are similar figures, we're changing both dimensions. Isn't the change supposed to be squared of what the sides do? So instead of setting it equal to 13 over 9.1, when we're doing the area, we have to square each of those to get the right relationship. So 60 times whatever 9.1 squared is, and then you're going to divide by 169, which is the side squared. So what's our missing area? Can't do it mentally, I'm sure. Did I lose you? $60 times 9.1 times 9.1. We're dividing by 169. 14?
No, 42.
42? 0.0 or 42? All right, so that was square centimeters. So when you go back to the section 7.5 that I'm going to have you do, we were doing proportions. What you need to know is what ratio to set it equal to. You set it equal to the ratio made up of the sides or the square of it. The difference is, are we trying to find a perimeter or an area? If you didn't write that one down, I'll leave it up there. Be sure to get that one written down because we didn't do too many examples. Okay, we better get started and see how far we get on our quizzes. But here's what the assignment problems will be. It could be a real fast assignment if you understood how to determine what the effect is. Let's see, what that's the wrong page. 491. 10, 11, 18, 19. This is back on that 7.5 section, I think. 8 problems from that section. And then the 625, what effect does it have? We'll do 1 through 11, and 30 to 33. Really not a real long assignment. Might be a good night to do some work on your project.
I forgot which calculator.
Yeah.
If we don't finish this, can we come in during the period?
Let me see if it's everybody's having trouble getting finished, and if so, then we'll extend some time tomorrow.
Oh.